Hello, and welcome to part 2 of our series on the Fischer Esterification. And in this video, we're going to look at an example mechanism for the Fischer Esterification reaction. Okay, and I'm going to try to keep this as a fairly simple example so I don't have to fill up my board too much here. All right, so here's my carboxylic acid. It is acetic acid, and I'm going to react that with ethanol. So ET means CH2CH3, and I'm going to use paratoluene sulfonic acid as my proton source, TSOH, and the ester we're going to form is this. Which is ethyl acetate, okay, plus water. All right, so acetic acid or carboxylic acid plus ethanol, our alcohol, forms ethyl acetate, our ester, plus water. I'm going to see if I can fit this whole mechanism onto one whiteboard, but we'll see. I may have to do 2 whiteboards. So this is a 6-step mechanism. So I might have to do 3 steps and then another 3 steps. We'll see. All right. So this mechanism, the mechanistic type, is an acid-catalyzed nucleophilic acyl substitution. So we're at a carbonyl compound. We're substituting something on that carbonyl compound at the carbonyl carbon, and we're doing it under acid-catalyzed conditions. All right? So the first thing that's going to happen, and a thing that happens very commonly under acid-catalyzed conditions, is we're going to start with a proton transfer, and we're going to make this carbon more electrophilic. We're making a better electrophile. Okay, and we're going to do that with our acid, toxic acid. And I prefer to see proton transfers as with 2 arrows. Oftentimes, our textbook will kind of abbreviate that with 1 arrow, but I like to make sure that I know that you know what you're doing. So we got two arrows in that proton transfer. All right, and I can already tell I'm gonna do this in 2 steps or 2 whiteboards. Okay. All right, so we make this protonated carbonyl. It's got a plus charge on that oxygen. Okay, this has 2 resonance forms. All right, that's why I'm putting it in brackets. I'm just showing one of the resonance forms. The second resonance form, we could form a pi bond here and have a lone pair go there. All right, so now we've got a good electrophile. Now we are ready for a lone pair nucleophile to come in. All right, and that, in this case, that's our alcohol. So we've done this step many a time in organic chemistry. This elementary mechanistic step is a nucleophilic addition. Add. All right. And that gets us to this. Let's see if I can fit it on here. OH. OH, OET. Okay, but we still have a proton on there. Okay, so we get this. And then we have 1 more step to get us to the halfway point. And I'm going to take another molecule of ethanol. Okay, and since ethanol is one of our reactants, I'm going to use it for the deprotonations in this mechanism. We could also use water potentially because we're making water in the reaction. Okay, so we're going to pull off this hydrogen. Okay, and that's also a proton transfer. And that gets us to the halfway point in our mechanism here. All right. So we could call this a tetrahedral intermediate because this carbon is now tetrahedral where it used to be trigonal planar. Okay, sp2 hybridized, going to sp3 hybridized. It's also called the ester, sometimes called the ester hydrate. Okay, and so if you imagine we went to our product and added water, we'd be hydrated. Okay. And so we did a proton transfer, a nucleophilic addition, and a proton transfer to get here. I'm going to erase all this and keep on continuing. All right, so this is a nucleophilic acyl substitution. So we're substituting something. Okay. So we've added this OET group. In the second half of the mechanism, we're going to lose one of these OHs, and I don't know that it really matters which one we lose. Okay, and to do that, first we need to produce a good leaving group, and we're going to do that via a proton transfer. Oops, we're going to use our acid to do that. Paratoluene sulfonic acid. All right, everything's under equilibrium, so I'm trying to show these arrows like that. So we do a proton transfer. Okay, it has a plus charge now, it's a good leaving group. And so now it's going to leave like that. And this is where we lose our water. Okay. Right. And this oxygen, I'm going to just reposition it up here, just because it'll look cleaner, I guess, or just because it makes me happy. Maybe that's the reason. Okay, that plus water. Okay. And then, ran out of space on myself. Trouble. Okay. So this was a nucleophilic addition. All right. And then our last step, we're going to remove that proton through a proton transfer. And I'm going to use ethanol to do this. We could also use the water. Okay. All right. We're not going to use the tosic acid because these are more basic than the tosic acid. All right. So this is going to squeeze through here, pull off that proton, and we're going to do that proton transfer. And that ultimately gets us to our ester. Okay, so there's our ester. So in this second half, we've got a proton transfer, a nucleophilic addition, and another proton transfer. Okay, so let me just summarize what's happening here. Okay, in organic chemistry, we always want to look for patterns. And the reason why we look for patterns is that patterns help us to memorize things. So we always want to try to synthesize things in our heads, look for patterns. But if we kind of look at the mechanism of this reaction, it's 6 steps. Okay. The first 3 are a proton transfer, a nucleophilic addition, and then another proton transfer. Okay, and then our last three are a proton transfer, a nucleophile elimination. Oh, I hope I wrote that right over there. I probably didn't. It should have been a nucleophile elimination. Okay, and then another proton transfer. Okay, so we could kind of summarize these first three and kind of call them almost like an acid catalyzed nucleophilic addition reaction. That's something we saw in chapter 18, okay? Like when we added acid catalyzed hydration of an aldehyde would be like this, okay? And then this last step where we're losing water, or these last three, we could call an acid catalyzed dehydration. Alright, so you can kind of chunk this into simpler things. But you can kind of note the symmetry here. Proton transfer, nucleophilic addition, proton transfer, and then we have another set of proton transfer. It's almost like a sandwich, like a double-decker peanut butter and jelly sandwich here, where you got the bread. Here you've got like the peanut butter, and here you've got the jam or something. So it might be kind of a weird, or the anti-peanut butter. Okay. All right, I better stop here before I go crazy with this mechanism. Thanks for watching.